Welcome to ARC problem part E, the conclusion, the exciting conclusion of our ongoing saga. We are talking about this problem right here, and again the text of this problem is in the HTML file that's in this folder. And we are going to do E, which is what is the velocity and position of the ball at an elevation of 60 meters from the ground on the way down. So we're looking at this problem here. And we know from this problem that this thing is going to go, when it's at the top, it's something like 83.3 meters at the top high. So 60 meters is right there. And again, we're going to be picking some spot here. And it said 60 meters on the way down. So there's 60 meters on the way up, 60 meters on the way down. And that's where we're looking, is right there. Okay? Which means we'll have a negative initial velocity, or a negative final velocity for the vertical. Okay, so I'm just going to use, it's the same launch velocity, so let's set up our horizontal vertical SUVOT here. Okay, and it looks like this, like that, horizontal, vertical. Right, and everything we're still on Earth, so it's 9.81 down, and this is 0. The horizontal velocity that we got from the first problem using cosine, right, is going to be the same velocity here, so 8.4457, and the final horizontally is the same, 8.4457 meters per second, The initial will be 40.427 meters per second. Right, and then our displacement, we know that we're going to be up 60 meters. That's the whole point of the problem, right? Is that we're going to be up 60 meters from where we started. We're here, we go like that, and we are going to be displaced 60 meters up like that. Okay, and now all we really need to find, it says what is the velocity and position. We need to find these guys. That'll be our position, over and up, and our velocity will be here, over, and then we need to figure out the up one there. So we're set. Right, so let's just solve away. We've got three things here. I'm going to find the final velocity first. Okay, v squared is u squared plus 2as. So therefore v is the square root, the absolute value of v is the square root of u squared plus 2as, which looks like this on the calculator. There we go. And I get that the absolute value of the velocity is 21.381 meters per second, right? Now, notice that the problem asks for the on the way down. So this is the way this works. The 21.381 is positive when it's here because it's going up, the vertical velocity, and then of course it's negative at this location. Right? And so we're going to put in here negative 21.381 meters per second. And the negative is because it's going down. Okay? And now we can also find the time for this. I'm going to use v equals u plus at. Okay? So negative 21.381 equals 40. Notice I've neatly sidestepped the quadratic equation here. 7, this is positive, plus negative 9.81 times t. Right? If we solve for t, that's going to look like this. And there's my solution. For that, I'm getting 6.300 seconds. 00, I guess we'd say 3.6301 seconds, yeah? Yeah, 301. And then of course, or I suppose I want 5 sig figs, right? So I'm going to say 005, there we go, right? And then time is on both sides, so it's 6.3005 seconds horizontally. Now we can figure this out. This is easy. S equals ut plus 1/2 at squared. Acceleration is 0. that guy goes away, right? So this is S equals UT, which is 8.4457 times 6.3005, which looks like this on the calculator. And there we go. 53.2 meters over, right? And of course, this is what we know, okay? The position of this thing is 53.2 meters this way, horizontally. Vertically, of course, it's 60 meters because that's what they told us to do, right? The velocity is 8.4457 over and 21.381 down. And so now we can take this velocity here and make the vector, right? Here's the object. It's going over. It's going down. It's going down kind of a lot more, right? 8.4457. That's our velocity there. And then negative 21.381 is that. We can find the hypotenuse, right? That's going to be the speed of it, which is the square root of 8.4457 squared plus 21.381 squared, which looks like this in the calculator. There it is. Notice that I'm leaving the minus sign off of there because you need parentheses, otherwise the TI calculator is going to do the unary minus last, okay, which isn't really what you want. Okay, so this ends up being 22.9886 with 3 sig figs. I guess we'd have to round up, right? I'd have to say 23.0 meters per second is our speed, right? That's our speed. That's the magnitude of the velocity. And then we could also find the angle, like this. And then we can find that. This angle we're going to find with the inverse tan. This is the adjacent side. That's the opposite side. So tan minus 1 of the opposite, which is 21.381 over 8.4457. Right? And if we do that, we get, there we go. Inverse tangent of that is 68.4 degrees. Right? So there we have it. We've got everything we need to know about it. It's moving down with a speed of 23.0 meters per second. Its velocity vector makes an angle of 68.4 degrees below horizontal. It's over 53.2 meters, up 60 meters. Ta-da!